All right. So thank you, Mark. Hello, everyone. My name is Clinton Hilliard, and I'm the programs director for Incose Chesapeake. And along with my co-host, Paul Martin, we will be administering tonight's Zoom event here. So I want to welcome everybody tonight for attending our August virtual lecture. A couple of preliminaries, though, before I start or introduce our speaker. First, we're going to be raffling off a door prize as we usually do to one lucky attendee tonight. So for those folks who don't have a display name that I can map to a registration, if you want to be included in the raffle, please update your display name or chat me so I can identify who you are and match that to registration. Second, we will have our questions session at the end of the presentation. But if you have questions during the presentation, please put them into the chat window. We'll queue them up at the end there for answer. And we'll have probably a 15-minute session at the end for questions. All right, now, tonight, I'm honored to have and introduce our special guest. He's a highly sought after advisor and speaker, Mr. Nicholas Chaillan. Mr. Chaillan is currently the appointed Chief Software Officer for the U.S. Air Force and is also the co-lead for the Department of Defense Enterprise DevSecOps initiatives. Serving in these roles, he holds overall responsibility for establishing force-wide capabilities and best practices. Prior to his current position, Mr. Chaillan was Special Advisor for Cloud Security and DevSecOps at the Office of the Secretary of Defense, Acquisition and Sustainment. He also served as Special Advisor for Cybersecurity and as Chief Architect at the Department of Homeland Security. There, he designed the innovative and holistic cyber.gov cybersecurity architecture. In addition to his public service, Mr. Chaillan is cyber expert, a software developer, and an inventor and technology entrepreneur who has founded several companies. He has over 19 years of domestic and international experience with strong technical and subject matter expertise in cybersecurity, software development, product innovation, governance, risk management, and compliance. Now, with all of that, I'll turn the presentation over to our speaker, Mr. Chaillan. Please take it from here.
Thank you, and thanks for having me. It's always interesting to me when I'm introduced to see that we forget that I was born in France, and they put a French guy in the Pentagon. That's pretty interesting, right? That tells you how far behind we are when it comes to tech. So hopefully we can catch up. But we'll share with you the journey of the last 2 years in the DoD and what we've been doing with DevSecOps and trying to show how important this is. And for that, I have a few slides to go along my little talk, and hopefully we'll be able to take your questions as well. I want to make this interactive as much as possible. So, obviously DevSecOps is about timeliness and about being able to compete and being able to rapidly adapt to challenges and work as a team. And for us, it could be a pretty large team with quite a lot of different technologies, including technologies we need to bring with us, even to space. And that, includes quite a bit of sensors and different modules that needs to be evolving and rapidly changing. And so agility and flexibility and modularity is critical for us to succeed and to keep up with the pace of all of them. And on top of that, we have quite a few people and multiple countries involved. And obviously that compounds the problem when it comes to training and scale. A couple of key concepts for us, right? One is we don't want to be locked into a cloud provider. We want to be able to run software anywhere, whether it's on the jets, whether it's on the space system, whether it's on premise, whether it's on the cloud. We want to be elastic. We want to be able to be agnostic to the environment. We want to be running on a classified system, air-gapped systems. And so for that, we picked Kubernetes, which is a container orchestration stack that's open source, owned by the Cloud Native Computing Foundation, came from Google, and containers. And we'll talk a little bit about containers and Kubernetes today to see how we use that. The first aspect and the first piece of what we've done is creating two enterprise teams. One is Cloud One and one is Platform One. As you can see, that's driven from Air Force One, obviously. And Cloud One is the cloud team that has access to Amazon and Azure. And Platform One is the DevSecOps team that is agnostic to the cloud environment and can run anywhere, including on jets and bombers and space systems and nuclear systems and so on. So all the stuff you're going to see today is not just done in a vacuum or on business systems. It is done on weapons. It's done at scale. And it's pretty exciting to see that we can move at that kind of pace on very complex weapon systems as well. So the good news is if you can do it, pretty much anyone can do it as well. We have a very strong stance, of course, on security. And my background, of course, is also in cyber. But because I'm also a developer, I guess I can have two hats, right? I can take a step back and really make sure that the balance between security and technology and development and compute engineering is there so we can move at the right pace, but also keeping our stack secure. And so we use Zero Trust, and we'll talk about the concept of a sidecar container security stack that we built that use behavior detection and Zero Trust, and we'll talk about what that means. We have to train quite a few people. I have to train 100,000 people in a year. So we're betting on self-learning capabilities because we know that train a trainer and all these kind of concepts will not scale. And also because the content is changing so quickly. A lot of the tech we'll talk about today did not exist 2, 3, 4 years ago. And so it's not the same pace that we used to have to deal with when it comes to IT, where you had 10, 20 years to understand the technology. We're really looking at only now what is really two to 3 years to master new concepts. And so that's been very interesting to see because that's a different kind of pace. And so having a stack that's providing content from the commercial side that is not biased to a single company and can scale and can provide a sandbox, a cloud sandbox, so we can put it to good use and learn while doing is critical. And so we partnered with the Linux Foundation, the Cloud Native Computing Foundation, and O'Reilly, the books, the IT books, to really bring this unbiased content to the DoD so we can train these 100,000 people. So the very important aspect for us is to share with the world. And so I open sourced the entire stack that we built. And so everything is open to the world. And so we have a website, software.af.mil, software.af.mil, AF Air Force, right? And that is open to the world, and anyone can go and see our publications, reference design, architecture documents, source code. We have pretty much everything accessible to the world. We have recordings, videos. We're showing how we're doing this on weapons. We're showing how we're doing this at scale. We're showing training content. So there's a lot of great information on that website. So always recommend that you take a look at it. So why did we pick Kubernetes and containers? The first aspect was to be abstracted and not getting locked into a cloud provider or to a specific product. We wanted to be able to be modular and be able to be decoupled from any cloud provider and be able to scale based on demand. And containers are immutable. So you can think of a container, if people don't know what a container is, it's not a shipping container, it's a software container, of course. And the software containers are very much like a shipping container. You can put your software in it. It's immutable. It can scale. You can duplicate it. You can harden them, and you can secure them. And you can put pretty much any software in it. It could be a commercial product. It could be open source software. It could be pretty much anything that you want to put into that container. Ideally, as small as possible and very precise in terms of capability. So if you think of a sensor, for example, a sensor could be a container, right? So the sensor itself could be containerized, and what you do with the data that come out of that sensor could change based on the weapon system, but the way you capture the data from the sensor is the same, and that can be shared across Navy, Air Force, Army, right? And so these containers become Lego blocks to build systems. And so you can think of the system now as a bunch of containers, a bunch of Lego blocks that will be put together in a different way to achieve a different outcome, right? And I can have different type of capabilities, whether it's AI, machine learning, deep learning containers that can have different concepts around their capabilities, and yet they can be centrally accredited, and that includes commercial software too. So we can ingest containers from industry as well. And Kubernetes is an orchestration stack. So containers need to be managed, they need to run. If they crash, they need to restart. We need to scale based on demand. So if there is more traffic, we have more containers. If there's less traffic, we have less containers. All these concepts are managed by Kubernetes. And Kubernetes is open source, but there are multiple companies like Red Hat, VMware, Amazon Azure, Rancher, Data2IQ, you name it. They have a product around Kubernetes, but it's still very much compliant with a CNCF Kubernetes compliance. And that guarantees that the APIs are designed in a way that's not creating any type of lock-in. So we know that the code will behave and work the same, whether you run it on VMware or Red Hat or Azure, Amazon or Azure, does not matter. And so that brings us resiliency because we have self-healing. So if containers crash, they self-restore. That brings us baked-in security. So the concept of a sidecar container is very similar to a sidecar of a motorcycle, right? So if you think of a motorcycle with a sidecar, you have this little sidecar connected to your motorcycle, and it goes everywhere you go with you, and you could disconnect it, but it's there if you need it. And with Kubernetes, we can automatically attach to any container a sidecar. It's another container that's just tagging alongside every container, and we can ingest cyber capabilities into that sidecar to know for a fact it's always going to be there, and it's going to do a lot for us. It's going to be able to capture logs and telemetry. It's going to be able to look at the traffic behavior of the container. So if it's doing something it's never done before, it's probably malicious, right? Like a bad actor getting access to one of the containers. It's going to do zero trust enforcement, which is really a fancy way to say that for container A to talk to B, it needs to be whitelisted. It's going to create an encrypted tunnel using mutual TLS to communicate. So even if my team forgets to do encryption, I don't care because the sidecar container will ingest and push a mutual TLS tunnel. So everything will be encrypted regardless if the team thought about it or not. And so that brings us a lot of baked-in security, really at a scale that has never been seen before. And if you were to compare with a virtual machine, an agent running, a cyber agent running on a virtual machine, if the first thing a bad actor is going to do is tamper with the logs, and the agent is pretty much worthless at that point because the agent is running inside the same virtual machine. But because the sidecar container is running alongside the container, that is creating that abstraction, and the sidecar is still able to see what's going on inside of that container and giving us the data we need and the trust we need to know that the system has been compromised or not. And then you have this concept of containers that become Lego blocks, and they can be swapped and updated with no downtime. So we call that rolling update. So in effect, you can update software hot live with no downtime, and that's thanks to the Kubernetes orchestration that's going to do that for you. So no fear of updating anymore, no patching, no manual patching, none of that. Everything is highly automated in what we do. We use the concept called infrastructure as code, or GitOps, which is a fancy way to say everything is code, and we don't connect to boxes to type commands. We connect to the source code repo, make a code change, and that code change is then deployed to production, in effect guaranteeing that no one is going to drift the system by connecting and typing stuff in production. And so that is really how we orchestrate everything we do. Everything is code, and that is a massive shift for testers, for cyber professionals, and all these different expertise people with their expertise have to shift to that code mentality, and everything becomes code. And that's a very interesting way to secure your design state because everything is now code that can be controlled and assessed, and you can have multiple set of eyes on code change to enforce change management and all that kind of concept. And that's also how we do hardware-in-the-loop testing and all that kind of stuff. We'll talk about that as well. But containers also let you auto-scale. So if there is more users or there is a need of more compute or memory need, you can auto-scale automatically and go up and down. So you pay what you consume. So that gives us a lot of flexibility. If we need more compute, it goes up. And then when we don't need it, it goes back down. The abstraction layer is also critical for us. And we don't want to be locked in. We want to be able to run on jets. We want to be able to run on any system really and not have to change these Lego blocks and have that kind of flexibility. As you can imagine, that's really game changing. And so being able to run software on any system, not have to worry about where that's going to run, and know we're going to have the same cybersecurity stack, the same visibility, is why we ended up also picking Kubernetes. So when you look at a DevSecOps stack and you look at all the pieces that are needed to build a pipeline, from the planning and development to the build, to the test, to the cyber scans, to the deployment operations, to the monitoring side, you have all these different tools and all these different pieces that need to be updated. And you don't want to be running these as virtual machines. They're gonna get stale. They're gonna drift. You're gonna need to update the stuff. If you run as containers, they can self-update. If you have multiple environments for dev, test, staging, production, and maybe multiple classification level for us, right? We have sometimes programs with 5, 6, 7 different classification levels, and so you end up running the same stack maybe 20 times, right? Because you have dev, test, staging, prod, unclass, secret, TS, right, and so on. And so you end up with 20, 25 environments to manage. And if you are running virtual machines, pretty quickly you're overwhelmed. And so we use containers to make sure that they self-update and we can swap them. So if a team is trying different things, maybe a different programming language, maybe a different tool, it's just a matter of swapping the Lego blocks. So when you think of the DevSecOps layers, right, we have the infrastructure layer. That's where we're going to have the cloud or the weapon system or the on-premise or classified cloud. On top of that, we're going to put Kubernetes with the platform layer. The continuous integration, continuous delivery pipeline, the CI/CD pipeline is containerized inside of Kubernetes. And then we have what we call the service mesh. And the service mesh is just a fancy way to say that it manages the traffic between containers, right? So container A talks to B. All the east and west, what we call the east and west traffic, the traffic between containers is kind of approved and controlled by the service mesh. And so that brings us really zero trust security by whitelisting the traffic. So that reduces the attack surface. If a bad actor was to get access to one of the containers, they can then easily be detected and then they cannot laterally move to the entire platform. And so for developers, what's left on the application layer is really maybe 10% of the NIST cybersecurity controls. So very easy to implement, a massive time saving, and really enabling massive reuse of code and a lot of flexibility as well. So one of the big things we've done is creating this platform one team that is really bringing enterprise services to all these different teams, all these different weapon systems, software teams, research teams, companies from industry, even other federal agencies as well. And we even have companies, right, using these containers as well. So that really helps people accelerate their journey to DevSecOps by reusing what we built. And that has been a critical enabler to help these teams move fast. We have dozens of locations, of course, and so we have people all over the U.S. and they all do different things, and that includes every kind of system you can think about, from nuclear systems to submarines to ships to jets to bombers to business systems. So AI machine learning teams and And so really touching every layer of DoD. So we built Platform One as a company, pretty much, even though it's run by in the government, because we know that if we have customers, happy customers, that's how we know we're doing things right. And so we build a bunch of services that bring different type of value, and people can use as little or as much as they want. And that's how we can move so fast, by having these enterprise services that are available to the DoD. The first thing we did is we created Wrapup 1, which is a source code repo of everything we do. All the infrastructure as code, the container source code, everything is there. And so people can use that. It's open to the world, which was fun to get approved by the lawyers. And then we have the Iron Bank, which is a source code repo of containers. That's the binary side, that's the compiled containers. We actually have now 170 containers. So we are going to 250 now. So the slide is a little dated, but we have 170 containers that are up and running on the Iron Bank, that are both commercial products and open source products that are centrally assessed, hardened, and approved for DoD use. And so people can go on that repo and download the containers to use them. So they don't have to do all the scanning, the patching, the updating, all this nonsense is done by my team at scale. And then, we have multiple options for Kubernetes. We partnered with dozens of companies, but the big ones, OpenShift with Red Hat, VMware, D2IQ Convoy, Oracle, Amazon, Azure, D2IQ, all these people have now access to and Rancher. All these people all approved and added to the repo of the source code. So it's already scanned and already secure and hardened for DoD use. And when we designed the stack, we wanted to bring two options, right? We wanted what we call the party bus, which is a multi-tenant environment where teams that don't have very specific needs and they just want to get started in DevSecOps and they don't want to build their own stack and they just want to use DevSecOps and they don't want to rebuild anything. They just want to build software. They can go and have an account. It's a pay-per-use model, so people, developers, the teams pay per developer to get access to the environment. And we do everything. We do the cyber ops, the IT, the licenses. We take care of everything. Multiple classification levels for us, and that is managed by the Platform One team. The teams don't get to pick the tools. They only use the tools that we end up picking for the enterprise. And then the other option is the Big Bang. And the Big Bang is a dedicated enclave. So bigger teams that needs to have maybe specific tools. We support 16 programming languages, 23 databases, all containerized, of course. They can then really have flexibility and build the stack they need based on their mission. And so we do that. We help them get it done and getting the stack accredited. And that's a pay-per-use model as well. The training is really critical. And so when you look at training, we want to bring self-learning capabilities. So we brought a bunch of training content. We have onboarding for the teams to get started. So we help them getting access to the stack. And then we have what we call a 2-month onboarding process to create a minimal viable product. So for teams that are just getting started, they want to get something done. They want to do something that can be done, rapidly to demonstrate their learning and their delivering capability. We put Platform One people into their team, and then they can learn and move fast and learn by doing. And that's really the best way to learn. And so having that 2-month onboarding process is pretty exciting. We bring a lot of tools, pen testing, contracts. So we really streamline access to chats and collaboration tools, and particularly during COVID, we were very little impacted because we have all these collaboration tools and all these options. So teams can just go and have access to chat and video and do all that kind of stuff. And so we provide these and we manage those tools and we host them and we secure them and we do that at multiple classification levels. A big impediment also for us was the contracts. And so we wanted to streamline the entire process, right? So for companies trying to do business with DoD, often it's a struggle to get contracts done. And so by really building a kind of dedicated contract vehicles, we have solved that problem, and we can award contracts within 30 days. And so we have 3 contract vehicles, one for cloud services, one for licenses, and one for talent and services. And that enables us to have programs, let's say F-35 can come and say, I need 20 developers, I need 5 DevSecOps engineers, I need the licenses of 15 different tools, and I need cloud compute storage. They can do that and go through our process to get it within 30 days. So very quick turnaround as well. In overall, when we look at what we've been doing, we saved in 1 year, and only with 37 programs, we're not 60 programs, but back then at 37 programs, we saved 100 years of time by moving to DevSecOps. And so you can think of how much is that worth, right? We are saving about 18 months per program per 5 years of time. Right, so every 5 years, we just took away a year and a half of time. That's how fast we're moving, or much faster we're moving compared to what we used to do before using DevSecOps. So one might say it's almost criminal not to use DevSecOps in 2020 and go back to waterfall and all that kind of stuff. And so we don't have the choice when you look at the pace of China and Russia and how quickly they can build capabilities and the size and the scale of the Chinese teams. We can't get behind, right? So we cannot have the luxury of time. And so timeliness is going to bring both better security, but also better capabilities if we can rapidly try things out, fail fast, but don't fail twice for the same reason, and learn fast and really find 1,000 ways that it didn't work, but at least you can find the right way to make it work, right? And so by being able to test things and try things out and have a very quick feedback loop with the end user and the warfighter, and not someone in the lab, but someone really in production, that is the difference between being relevant or not being relevant, right? So that is pretty exciting. I see there's a question, so I'm going to take that question at the same time. I think it's always good to break a little bit. So what advantages in time and cost metrics are expected for assessment and authorization activities leading to ATO for new capability system being built upon Iron Bank containers? Is ATO renewal reaccreditation automatic or easier if Iron Bank containers are used as infrastructure for new capabilities / systems? Well, you're spot on. It's actually even better than that. We created a concept called the continuous ATO, continuous authority to operate. And a continuous ATO is different from a fast track ATO, accelerated ATO, or whatever you want to call that. A continuous ATO is about accrediting the software factory, the DevSecOps pipeline, and the gates within that pipeline. So we have change management gates, which means how many set of eyes on code do we have to approve code change. That creates change management, enforcement, and the mitigation of the need to know list privilege and separation of duties, right? Then we have test gates, so unit testing, integration testing, end-to-end testing. And then we have cyber gates with static dynamic analysis, fuzzing, pen testing, and even container scanning and bill of material, right? Dependencies, and that kind of stuff. So these are gates in the pipeline. And when we accredit a factory, a pipeline, like Platform One, then we authorize teams to use it. And so that's really scalable. And the software that comes out of the pipeline is automatically accredited multiple times a day. You can push software 1 million times a day, 1 time a day, 1 time a month, I don't care. But what comes out is already accredited. And so in effect, it's a DoD-wide accreditation. It is all the way to SAT, so it's really the highest specification level. And it is fully automated. I mean, we do have gates, of course, for nuclear surety and airworthiness in terms of manual testing, and that's completely fine for those systems. But the software remains continuously accredited. And so when you think of that, it's not just using the containers from the Iron Bank, it's using the platform and the containers, it's a bundle. right? And so if you use a platform, so you get the cyber stack, you get the continuous monitoring, you get the behavior detection, you get the cyber scanning, you get the zero trust stack. If you use that and use the containers, now any container can be accredited and be deployed on any of these platforms at any classification level. And the accreditation is continuous. It's not a one time a year or one time every 3 years. It is every day, as often as you need to push software. And so I would say that's really game changing. We estimate, in terms of time, we save between 8 to 12 months of time per program per 5 year of time for ATO alone, right? Just for the ATO process. So hopefully that answers your questions. The key DevSecOps ingredients, right, is, and really the concept of GitOps and no drift, so everything is code, so I can tear down the entire factory and bring it back up with the entire stack and the entire weapon and the entire system. All I have to back up is my Git repo and my databases. Everything is code. There's no change in networking or configuration change that is not code in the Git repo. No one goes in production, goes to SSH, type commands and change the firewall rule, and then forgets about it, and then we redeploy the stack and it's lost, and now we have bugs and issues. That does not exist. In fact, there is no one in production. The production system pulls from Git. It's a continuous pull of Git by using branches in Git. And so we have multiple set of eyes to approve code change, and often 2 or 3 set of eyes based on the criticality of the system. And that's how we enforce need to know and separation of duties and the change management process. And then we have continuous monitoring. That's where we bring all the logs and telemetry for all the containers into a central place. That's where we have the zero trust automated alerting. So if a behavior of the container change and we see maybe a bad actor trying to do stuff or do something malicious, we'll kill the container proactively. And so we have that automated prevention capability and CV scanning, that continuously scanning the stack in production to see if there's new CVs or new issues. I see a couple more questions, so I'll take a couple more questions. What are the limitations of the static and dynamic analysis tool? So we have multiple options. We bring, checkmarks, SonarQube, we bring a Fortify, each have different benefits based on the programming language and all that. So we let teams pick. But we do have thresholds. What I mean by that is to pass the pipeline, you have to be doing better than X, Y, and Z, right? So based on the findings, if you have critical findings, you cannot pass the pipeline, you have to fix it. If you have less critical findings, sometimes we give 5 days, 10 days to fix it, or sometimes they have more time. So those are based on those different tools, and that's just bringing options. But for us, any tool is a container. It's very easy to bring more options. It's just a matter of finding the right commercial products, open source products. So hopefully that answers your questions. And then how complete is a CV to make the scanning effective? We have also multiple tools. On the container side, there's a new set of tools that do CV scanning for specific to containers. We have StackRock, we have Encore, we have Twistlock. And so these, we mandate 2 tools per pipeline. So we have 2 scans of CVEs, so we can see if there's false positives or if there's gaps or something missed by one of the tools. So having 2 helps mitigating that. And they're pretty complete. I think we picked those tools based on the analysis by NSA of some of these tools, and they were the most competing, both in terms of lower false positives and also higher rates of finding problems. And not just CVEs, it could also be configuration issues, it could be STIGs gaps. I mean, there's a lot of stuff those products can do. It goes beyond just CVEs, but it's pretty complete. So for there's a question about everything is code, what language? So we use Terraform when it comes to orchestration, and then everything on Kubernetes is using YAML for orchestration on Kubernetes, and a lot of Go on Kubernetes as well. But Terraform is a way to orchestrate your IAC and be agnostic to the cloud. You're not building code that's only going to work on Amazon or Azure, we can run on the weapon, right? We can deploy this whole stack on F-16 jets, on 20-year-old legacy hardware, right? So that is possible because we abstract everything. And then Zero Trust, can users build their own code? Yes, they can build their own code. You know, they have to go through the training, of course, and be allowed to have access to the development environment. But yes, they can do that. And then if there's time, can you go into the concept of chaos engineering? Of course. So chaos engineering is a concept that came from Netflix. It is all about resiliency, right? So you crash stuff on purpose, first in staging and then even in production, to demonstrate how resilient your system is, right? The only reason why Netflix did not go down when the East Coast of Amazon crashed is because they actually emulated and practiced that crash, right? So chaos engineering is literally crashing stuff on purpose to see how resilient your system is. For example, you know, SpaceX knows exactly which container is needed to run the rocket with no issue. They also, a company like Netflix that has 700 containers know that only 20 are needed to watch a movie, right? And they know that because they crash the system and see what is needed to watch a movie. And other containers can be either cached or emulated or just go down and not have impact, significant impact. Good example is, let's say the list of movies you need to watch next, right? So you want to have that cool list of movies that is designed according to your what you're watching and to yourself, right? And so that's a microservice, right? They give you the list of what to watch next. Well, if that microservice goes down, the system is not designed to have a massive error message and tell you to wait or whatever, right? What it's gonna do is either they're gonna have a cache version of your list, so they cache that on your device, and that's where you can display the list anyway. So you can still have the list, and if you have no cache, then it's just gonna display a list of 5 random videos because it's better than having the system go down. So in effect, it's called graceful failure, right? It's still making the system behave as good as it could, even though some of the containers of the system are not up and running. And so the chaos engineering lets you emulate and really understand what are your critical core microservices and containers, so you know exactly which one are critical to your system. And one might say there is nothing more important than this, right? Because you're running a weapon system, you need to know which microservice are really critical to your mission, right? If a sensor goes down, is that a sensor that is completely, absolutely needed to do your mission, or you have redundancy, you have another option, if your GPS sensor, if your radio goes down, you have another way to communicate, right? So by knowing this, it's pretty critical to make system resilient and reliable. Hopefully that answers your question. And then, does this design eliminate the need to have everyone clear at the highest level of the information? Yes, absolutely. And that's also the benefit of cutting software from a big monolithic application to microservices, containers. Now you have smaller blocks, and you don't have to give access to the whole system, and people don't have to know every detail of the system. You can build Lego blocks without really knowing how they interact or what they end up doing. For example, if I build a sensor, I don't know what the system does with a sensor and what the data is being used to do maybe a weapon firing something, or who knows, right? I just build a sensor. I probably don't need that to be classified. All that does is it's capturing data from the sensor. You have no clue what that's being used for. So in effect, you can really lower the classification of the code because of that, because it is segmented and siloed into smaller code base, and we can have change management and access control very granular down to smaller teams. We use the model of a 2 pizza team that came from Amazon, which is you can feed the team with 2 pizzas. Of course, if I'm on the team, you're going to have less people because I eat a lot of pizzas, but it's usually between 7 to 12 people. So hopefully that answers your question. So a lot of people don't know much about service mesh. And when you move to microservices, you're going to have all this traffic between containers, and that's a nightmare, right? And you don't want to have to coordinate. You know, I issued a memo in the DoD to highly discourage the use of safe and all of these agile, outdated principles that coordinate releases. The commercial side is not coordinating releases. You can release at your own pace. Each team is able to release software without having to wait for the other team to release or to coordinate a release train and release software at the same time. That's a completely outdated way of thinking. The point of having microservices is so you can release software at your own pace, and each team can have its own release cycle without having to coordinate anything. And the only way you can really do that, because containers and microservices need to authenticate, they need to communicate, they need to encrypt data. And usually, back in the day before the service mesh, you had to share libraries and share dependencies between teams. And so when they update the dependencies, let's say you change encryption or you change authentication mechanism, now you have to coordinate the release because you have to share these bits between teams. And that's obviously creating a massive bottleneck and creates the concept of a release train and coordination between teams. Once you move to a service mesh, all that stuff is now done, created inside what we call a sidecar container. And that sidecar can be updated seamlessly across all the teams without having to touch the containers, right? So in effect, each microservice, it could be in different programming languages, it could be one in Python, one in Go, one in C, one in Java, whatever, I don't care. The sidecar container is going to do the authentication, the service discovery, the management, the routing, load balancing, the zero trust enforcement to whitelist traffic between container A and B, the encryption. All that is done by the sidecar container and enables the team to not have to worry about that and decouples that from the application. And you can update this without impacting the teams. And so now we have a service mesh team that's responsible for allowing traffic for container A to talk to B, but it's also responsible for encryption, for load balancing, and all that kind of stuff, and creating high availability services without having to coordinate releases and without being tightly coupled to a programming language, so you can have that work on any system, any programming language, even if a team is using Java and one is using Ada, one is using C, whatever, I don't care, it's still gonna be able to do the job. And the Istio is what we use. It's open source. It's a service mesh that uses Envoy, which is a sidecar proxy. All that is a sidecar is a reverse proxy. So what that does is it's hijack the IP table, and all the traffic is tunneled through that proxy, and that's what's going to do the enforcing of encryption, authentication, load balancing, RBAC, the whitelisting of the traffic, all that kind of stuff. And yes, the zero trust model also does some ABAC. We have ability to use, SAML and JSON web tokens and stuff like that to have some type of, parameter or custom variable to enforce a more granular attributes for ABAC. So it's RBAC and ABAC, absolutely. So people ask us, what are the benefits of ISC and virtuous code? And again, if everything is code, all you have to bring, I can spin up an environment with a push button deployment and walk away and come back in 2 hours, and I have a full DevSecOps stack. And I know it's not going to drift from the other environment. It's going to be the same. Everything is going to be exactly the same. It's immutable. It's replicable. It's automated. There's no human in production. So we reduce the attack surface. We can disable SSH. We can reduce insider threat, configuration drift, right? Every change is a code change. Like if I want to whitelist container A talk to B, it's a code change that's going to go into the service mesh team, and the second approver or third approver will approve it. Once they merge the code into the master branch, that's going to be pulled. And by the way, we pull from Git. It's not a push from the CI/CD pipeline to staging or to production. It's the staging or production that pulls from Git every minute. So it's actually checking every minute, hey, do you have a code change? Do you have a code change? And if the code is approved and passing the gates and passing the pipeline, then it pulls that change to apply it into the production environment. So if I have a bug and I want to revert back, the system will check every minute. and will revert if you have an issue, you can revert back to the previous version and go back in time and redeploy the previous version. So it creates this kind of immutable architecture that's all code driven. So your source code, just reading your source code, you should know your desired state of your system, and you can compare what's running in production from your source code. And if you have any change, any drift in production from your desired state, you know that you have an issue. Probably a bad actor got access to your system and deploy stuff it shouldn't deploy, or some malicious insider managed to get access and make changes. But the fact is, your production stack should not diverge from your source code. And GitOps is kind of the evolution of that, right? That means just everything is Git. Git becomes the source of truth. Everything is code. Your audits, your compliance, your configuration management, enforcement, your disaster recovery. Think of how easy it is to back up your source code and back up your database, and now you have a full disaster recovery stack. You can take it down every night and bring it back up every morning for all I care. It's going to spin up the exact same stack. There's going to be no drift. And so everything becomes full, so you have no one with access to the cluster, no keys of the CI/CD pipeline, has no keys to the production environment, no human in production, because the production pulls from Git, so the production has the keys to the Git repo, but the CI/CD tools don't have the keys to the production environment. So everything becomes declarative, and all these source code becomes your desired state in Git. And so we use Argo CD, which is open source, to do that. That is what does the tool every minute to check if there is a code change and apply it to the system based on the different repos that we use to segment the systems. And keep in mind, each container gets its own repo, and the service mesh team gets its own repo, and the platform team gets its own repo, so we can re-segment need to know and least privileged users and really limit who has access to what. And we do code merger, right, to approve code change. So not one user can push a code change without having someone else approving it. So I see a question, is it continuous monitoring? Does continuous monitoring leverage assigned code for integrity and release management? Yes, everything we do, we sign the source code and we sign the containers. And we use project like TUF, TUF, and Intoto, EIN-TOTO, to be able to do multi-party signing. So we even go beyond that. It's just not one key, it's multi-keys. So even if we lose one key, or if one key is compromised, the bad actor would not be able to tamper with that, and that mitigates the key loss or key compromise aspect of that. So we sign and we do a checksum, and we have kind of that integrity assessment baked in for the release of the software. Absolutely. So we talked about a continuous ATO. Like I said, we accredited the factory and the gates within the factory, and it has to be running on a platform that's accredited, like Platform 1 with Kubernetes and our cyber stack. And then we authorize teams to use the factory. Like you said, developers are trained to have access to the factory. We do background checks, of course, based on the clearance and all that kind of stuff, based on the factory clearance needs. If it's a factory running on the top secret side, or if it's running on class or whatever, we check obviously that. And then we have a training, on onboarding training, to make sure they understand all the stuff we talked about today. And that can go anywhere between 3 days to 2 weeks, right? And that's how we onboard developers on the stack. And developers could be, airmen, but of course we have massive number of contractors and partners that are not airmen, right? So that was kind of my slides. Hopefully that was helpful to you. And of course, if you have more questions, I'm happy to answer on the chat. Hopefully that was not Chinese or French.
Thank you, Mr. Chaillan. is there, I think the good thing is, I think you answered a lot of the questions in line. So, but if we still have more questions, please offer them up. We're also going to leave the session here open after this for folks to just chat if they want for a little bit. For those who want to hang around, you don't have to hang around, but some folks tend to like to chat. If there aren't any more questions, I will, or while let me raffle off the book while people are thinking of more questions. So brief break here. Let me share my screen. Where's my share? Whoops. Okay, hold on a second. Here we go. All right, can people see the Wheel of Fortune here? I'm gonna.
Yes, we can see it.
I think I got everybody who's in the room. I don't have everybody's full name, but it's looking like tonight's winner is Michael Tucker. All right, I'll contact you, Michael, using the email that you registered with to get your mailing address.
Congratulations, Michael. Good job.
Congratulations. Now, so let's see, Mark, did you have a question there?
Yeah, I just thought that not allowing humans in a production environment was a really key idea to the whole operation of the enterprise. And I just wondered what specifics you used to enforce that.
Well, we just don't even have the ports open for them to connect. You know, that's simple. if you can't even connect, I guess you have no humans in production. You know, so we don't even have SSH or any ports open for the production environment to even let humans connect to the system.
So they can't get any source code or any development environment, right?
Yeah, so everything is segmented, and the source code side, of course, is on the development enclave, and then the production pulls from that Git repo to be able to replicate that code into the production environment.
Okay, thank you.
Yeah.
Can you hear me? One thing we'd like to do is maybe get a quick shot of everybody. I have everybody in gallery mode here. If you could just, and this is completely voluntary, if you just turn on your video for a few seconds and I'll take a picture. We got Nicholas, me, Michael, our famous winner of the book. He's going to write us a book report, right? I would love to put this on the website to show everybody who was here. That's
as long
great.
as I can automate it, right?
Oh yeah, I wonder if you could automate the book report, and you know,
AI, with AI you can do anything. Yeah,
Hey,
just use some AI.
All right, we got most people. Anybody else? We're going once. I don't blame you if you're in your robe and you don't want to be shown. That's fine. Yeah. Okay, I'm going to print this screen. There we go.
And everybody,
I should have said smile. Everybody smile. There we go. Oh, we got Gary up. Okay, one more time. There we go. Good job. Thank you, guys. I really appreciate it. You can turn your video off now. But Clinton's right. We'll stay on as long as people want to talk. Nicholas, if you want to stay and answer more questions as people come in. It really was a fountain of information you gave us, and I'm glad you had all those links. I'm going to put those on our after action report. So.
Yeah, no, thanks for having me. You know, we do Ask Me Anything sessions every 3 weeks. So in fact, it was today, so you missed it. But every 3 weeks we have people come, and I usually have between 800 to 1,200 people come and ask anywhere from 100 to 500 questions. So obviously I can't answer everything, but we try. We had maybe about 50 questions today, so I do that in 2 hours. So feel free to join us. It's always announced on the software that I have, the main website and on my LinkedIn. So if you want to follow us, also we're on LinkedIn as well.
Perfect.
Nick, I was curious, do you extend that beyond the DoD to other federal agencies to cooperate with?
Yes, it's open to anyone, even industry and companies, so anyone can join. It's really open to the world. And I see the question, what is the U.S. government strategy with many somewhat competing virtual computing, cloud contracts, JEDI, GovCloud, etc. So JEDI is supposed to become the big push for DoD, but we have Cloud One. Cloud One is Amazon Azure. So that's using also the IC GovCloud for C2S and SC2S for classified cloud. So Cloud One is kind of what we use. That's both unclassed, secret TS, and SAP. And that's using both Amazon and Azure.
Yeah, I was wondering, what was have you been getting any reaction from the other forces? I mean, your Air Force, as Army or Navy or others have been interested in what you're doing or trying to do a joint type scenario, type situation?
Yeah, so I have two hats, right? So I'm the Chief Software Officer for the Air Force, but I'm the DevSecOps co-lead for all of DoD. So that's with DoD CIO.
Okay.
So Platform One is a DoD-wide service, and it's available to everybody. And we have the Navy and the Army also using it as well. But it's at their discretion, so they have no mandate to use it.
Great. Okay, good. Okay.
Some are faster than others, so but that's okay.
All right. So Clinton, I think if we can keep talking, people, if they need to go, they can go, but this would be the end of the meeting. I don't think there are any other announcements, are there? Or
There's one last one. I want to just remind people of next month's speaker is actually another DoD speaker, but he's one of our very own Chesapeake chapter members, and it's Dr. Keith Willett.
Yeah.
So he's going to be speaking next month for us.
Yeah. Be sure to sign up.
Can you remind me where he is sitting? I heard the name, but I'm not sure I remember who he is.
Dr. Keith Willett.
Yeah. What's his role?
Systems engineer for the intelligence community.
Oh, I see. Okay. Makes sense. I heard the name.
Yeah, he's. If you go on our website, incose-cc.org, we have his bio, but it is kind of vague. But he's kind of a futurist with one of the local agencies here.
Yeah.
So.
Make sure you go to the Chesapeake chapter's website, not the international website.
Right.
Yeah, I saw that.
His whole bio, or the advertisement for the talk that's coming up next month is there.
Right. And by the way, that website's open for our members. If you want to, like when Michael does his book report, I'll be putting that on as a blog. So anybody, if you have some things you want to say, send them to communications@incose-cc.org, and we'll put them on for you. We'd like you to send a nice picture of yourself too. We'll put that in there too. But yeah, it's open to all our members. So please, let's make our blog something where a lot of system engineer, our website, where a lot of system engineers go to. It'd be good. So, all right, I'm going to sign out, but the rest of you keep going. So.
Yeah, I have to go eat before I pass out too. But thanks so much, guys, for taking the time.
Thank you very much, Nick.
Thank you.
Thank you, Nick.
Bye-bye.
Bye-bye.
Thank you.